So hey guys, welcome back to my channel. Hope you are doing extremely well, and this is your very own mascot at this side. So today we will be talking about pairs violating the BST property, right? Okay, so let's see what does the problem say. So the problem says that you have been given a binary tree, right? You have been given a binary tree. It is not a BST, it is not a BST, right? It is not a BST, right? It is not a BST. It is a binary tree, right? As you can see. Now, the questions demands you to mention how many nodes have to be swapped such that this has to be converted to binary tree. That is, how many pairs are violating the BST property. The BST property. So I know that you might have understood that to solve this problem, you have to be familiar with the BST properties. So the BST properties are very simple. The BST property says that for every node, all the children in the left subtree, that what is the left subtree? So for 80, it is 40 and 70, should be less than the node, right? So it is 80, so 40 should be less than 80, 70 should be less than 80, right? And similarly, for every node, all the children in the right subtree should be greater than node, should be greater than node. Okay, for every node, all the children in the right subtree. So what is the right subtree for 80? It is 30, 60 and 70. All right. Now the questions demands you to tell me the pairs which are violating this property, which are violating these properties, such that if you can see the 30 is actually less than 60, but according to the property 60 should have been less than 30, right? Because 60 is on the 30's left. So this is a pair that is violating my property. So 30 comma 60 is one such pair, right? 30 comma 60 is one such pair. If we travel more, I see that 70 is actually is actually less than 80, but 70 is on the right of the 80. So 70 should have been on the left side, right? But 70 is on the right side. So 70 comma 80 is another such pair, right? If I explore more, I would see 70, this 70 is actually less than 40, is actually greater than 40, but it's still present on the left side. So 40 comma 70 is also such a pair, right? Now if I try more, so 60 is actually less than 80. 60 less than 80 is still present on the right. So 60 comma 80 is another example, right? Okay, now 30 comma 80 again present on right? Okay, 70 comma 80 is already explored, right? Okay, now what do we say? 40 and 30 are also not a valid pair. Why is 40 and 30 not a valid pair? That is a question. So suppose I have my parent here, I have my left subtree here, I have my right subtree here. If these all values, if L is less than P, P is less than R, does these two properties say that L is less than R? Does these two properties transitively say that L is less than R? That is, all the children in the left subtree are less than all the children in the right subtree. So I am defining a new property. Not defining, it is actually pretty evident that all the children in left subtree are less than all the children in right subtree. Hope I'm clear here. Hope I'm clear. There is no confusion, right? So 40 comma 30 is one such pair that 40 is actually greater than 30 but still present on the left subtree of the 80, right? So 40 comma 30 is one such pair, right? So up till now we have discovered 6 more are present. 70 comma 60 is also one such pair, right? 70 comma 30 is one such pair, right? 70 comma 30. So how many pairs are there? There are 30 comma 61, 2, 3, 4, 5, 6, 7, 8. So the answer is 8 for this problem. The answer is 8 for this problem. But I would like you to see that GFG has told us the answer for this problem is only 5. They have mistaken. They are mistaken because I am submitting the same code in which I am using the algorithm for this approach, and my answer is giving to be 8 and it is submitting correctly, right? Okay, so GFG has just done some mistake in in providing the input test case, right? So don't worry about that. Okay. So now how to solve this problem? How to solve this problem, right? You are here to see the approach only, I guess, right? So how to solve this problem? So approach, right? Like intuition. This is basically the intuition, right? So my tree is 80 connected to 40 connected to 70 connected to 30 60 70. I think I have replicated the same tree, right? Okay. Now, suppose this is a BST. Suppose this is a BST. So if the given tree is a BST, so now I can remember that BST has a property that in order of BST is sorted in nature, is sorted in nature. Okay. So let me take the in order. Let me take the in order. So now I have devised a basic property for in order. What do? You drop the bars down at each node, right? Okay, drop the bars down at each node. Start traversing from this side. 1, 2, 3, 4, 5, 6, 7, 8. Traverse, traverse, traverse. Node finished. As soon as you intersect one, that is your first node in the in order. 70. Then 40. Then 80. Then go along the path. Like draw a boundary, right? Draw a boundary from the here, from this point, draw a boundary. Okay. 60. Now again rotate 30. Right? Okay. Then 70. Then all my nodes are traversed and I have got my in order traversal. Now you can check with your techniques that this in order is correct. And this is actually very much simpler for the complex trees, right? You just drop the bars down and draw the boundary, right? Okay. This is my in order, right? So if my in order is sorted, then I will have 0 pairs, right? But if my in order is not sorted, I will have to find the number of pairs, right? Okay. So my answer for this question which we found above is 8. My answer for this question which we found above is 8. My intuition says that the answer, this 8, will be calculated by finding the pairs. If I find the pairs in order traversal such that A of I is greater than A of j, A of I is greater than A of j, but I is less than j. Suppose it is something like 80 then 70, right? So 80 is coming before 70. This is not sorted, right? This is a pair. 80 is coming before 70 and this is a pair. So this will increment my answer to 1, right? Okay. So I am saying find the pairs in the in order traversal such that the larger element is occurring before the smaller element, right? So suppose you can see that 80 is actually coming before 60. So this is one of my valid pairs, right? 80 is coming before 30. So this is another pair, right? 80 is coming before 70. So this is another pair, right? So now talking about 60. 60 coming before 30. Another pair, right? Talking about 40. 40 coming before 30. So another pair, right? 70. 70 coming before 40. So this is another pair. Before 60, another pair. Before 30, another pair, right? So what are the pairs we wrote down just? So we said for 70 it is 40. So for 70 it is 40, 60, 30, right? Now for 40 it is 30. For 80 it is 60, 30, 70. For 60 it is 30, right? Okay. Now these are the pairs. Let me count them. So 1, 2, 3, 4, 5, 6, 7, 8. the answer is coming out to be exact same. And now this is your homework to match these pairs, with these pairs. Are they all same? Are they all same? You have to check them out. They are actually same, but you can check for their confirmation, right? So this will be my approach. My approach will be carry out in order, carry out in order traversal, right? And while carrying out, actually store the in order traversal, right? After that, my second step will be find number of pairs in order traversal, in order traversal, such that I is actually less than j, that is I is coming before j, and a of I is greater than a of j, right? So 80 is coming before 70. This is the condition. I can say it mathematically like this, right? Okay. Now how to solve this problem? That is our next problem, right? So first problem to solve is, so if I have my in order as 70, 40, 80, 60, 30, 70, right? 70, 40, 30, 70, 40, 80, sorry, 70, 40, 80, 60, 30, 70. This is my in order, right? I have to see this approach, right? So what I will do is, I will keep my I pointer from 0 to n minus 1. So suppose my I is here, I have to traverse my j here, then here, then here, then here, then here. If my I is here, my j will go from here, 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 here. My I is here, j will go from here, here, here. My I is here, then here, here. My I is here, my j will go here. My I is here, nothing I can do, right? So for I going from 0 to n minus 1, that is the last index. J will go from I plus 1 up till n minus 1, right? J will go from I plus 1 to n minus 1. So this property has been satisfied. Now this property. So if a of I is actually less than a of j, in that case answer plus plus. I will take my answer to be 0 in the starting before starting the traversal, before starting the nested loop, right? Okay. What is the time complexity? What is the time complexity? The time complexity for this case is O of n square. And what is the space complexity for this approach? So I'm actually using this extra space for in order traversal, right? So space complexity is O of n, right? Can I reduce the time complexity? Can I reduce the time complexity, right? So to reduce the time complexity, let me mark the condition again. My condition was I less than j, a of I greater than a of j. Just give a little stress to your mind. Don't you think that you have already encountered this type of problem? See, I'm assuming that you have done some amount of DSA, right? Okay. So this problem is actually the blueprint of count inversion, right? Count inversion. The problem is actually of count inversion, right? It has just been given the BST, so something inclined towards binary search tree, but the main problem is count inversion in this case. The exact problem to solve is count inversion. The count inversion solves literally the same problem to provide the number of pairs such that this condition pertains. Count inversion is based on this problem only, and the time complexity for count inversion is O of n log n, and the space complexity is O of n, right? Okay. So my reduced time complexity will be time O of n log n. My space complexity will be O of n, and this is my optimized approach. Now you will say, why are you ending this video right now? Why don't you explain us the count inversion? Okay, I get your emotions, but why to make a content more number of times if you have already uploaded them? So I've already uploaded the video for count inversion when I was solving the Love Bubba DSA sheet for you guys. So you can watch my video for count inversion. I will provide the link in the description, right? Okay. Now the coding area, we will also use the GFG code. I've already uploaded of the count inversion while solving the Love Bubba. Okay. So I hope you get my point, right? Okay. So let's come to the code real fast, right? So let's come to the code. So okay, pairs violating BST, right? So first step was to store in order traversal, right? Store in order traversal, right? So for that I will make a vector of type int, right, and name it as let's say A only, name it as ARR. Okay, name it as ARR. Okay, and then I will do the in order of root with ARR, right? So let me define the in order function. So void in order taking two parameters. One is of type node star root, and another is of type vector int, and I am sending it by reference. So vector int and root ARR. So if my root is not null, in only in that case, what do you do? In the in order case, you first traverse to the left subtree. So solve for in order root left with the same array, right? Then you push the root value. So ARR dot push back root value. Data. In the GFG it is defined as data. In the lead code it is defined as roots value, but I am using GFG, so I will be taking off roots data. Data. So now going to right part with the same array, and then at last return. Right. This will give me the array of the in order traversal. Now I just want to return. I just want to return count inversion of ARR, right? So I will use the code already uploaded in the GitHub with the video link. The video link is provided in the description if you want to understand what is count inversion and how it works, right? So I will just copy paste it. So I'm just taking the copy. Oh, sorry. Yeah. Okay, so copied it. I'll paste it here, right? So you can see the question of count inversion was actually given in the long int, right? So what I will do is it has to take an array, right? So I will change it to vector int here. So my array will become vector int, and I will send it by reference ARR. I will just copy it down and I will use it same wherever I'm using sending my it as parameter, right? Vector int ARR, vector int ARR, and okay. Now what I will do is you can see it is taking long n, so I will want an long integer because I'm given an n here in the int form. So what I will do, I will make a long n as simply n, and I will say return int version of, because this is returning long int, right? So I have to return int. So int version of the function's name is inversion count, and send your array with your capital N, right? This should work fine. Let's hope it works, and the results will be shown shortly. Okay, so it is working fine for compile and run. Let's try it for submit also. In the meantime, if you're new here, the request pertains, please subscribe to my channel. Please connect with me on my Instagram, my LinkedIn, and ask your doubts here. Recommend something that I can make for you, right? That would enhance your coding journey, right? Okay. So thank you for watching. Hope you liked it, and we'll meet tomorrow with a new question and a new energy. Thank you. Have a nice day.